Good afternoon. Today we will be seeing the concept of searching and followed by sorting. So first we will start with the concept of searching. Now, when we search for a particular element, let us say inside an array, then we have two methods of searching through which we can search the element. The first method is known as linear search. The second method is known as binary search. So we have two methods of searching. The first one is linear, second one binary. Now let us see what is the difference between these two. Now let us first come to linear search. In linear search, what happens? We have all the elements in an array, let us say, and we input the search element. We are going to search the element in the array starting from the first index, go on comparing till the last. In between, if we find the element, we print it is found, we come out, no need to check further. But if we do not find the element, then I have to check the whole list or whole array till the last. So in the worst case, the checking will go till the last. So if there are 100 elements, I have to search 100 times to come to the conclusion that the element is not existing in my particular list or my array. Now, that is the concept of linear search. We will go to the example, then we'll go to the coding. Let me give a brief idea about binary search. In binary search, what happens? As the name suggests, binary means 2. So here we are going to break our array into 2 parts. Now, but before going for breaking the array into 2 parts, there is a concept which has to be kept in mind. The concept is this binary search can only be applied to sorted arrays. That means if my array is not sorted, then we cannot go for binary. So binary search is only possible if we have the elements present in the sorted order. So if they are in sorted order, then we are going to break it into 2 halves, compare the element with the middle. Once I compare the element with the middle, I will get different options. It may match, or it may be the middle element may be greater than the element, or the middle element may be less than the element. Now, depending on that, the next time I only search either the first half or the second half, and this process goes on. We will see the details. So let us first come to our first one, that is linear. Now let us take an example for linear search. I have, let us say, an array. Now in this array I have some elements, index number 0, 1, 2, 3, 4. This is my array. Let us say the elements are 8, 2, 6, 4, 1. I want to search a particular element, let us say n. Whether it is present in my array or not, I will input the value of n. Let us say I input the value of n as 6. So now 6, whether it is present or not, how do we check? So what we are going to do, we are going to start a loop. This loop will start from 0. First, I am going to compare this with a of 0. Does it match? Now here in this case, it doesn't match. Since it doesn't match, next I will be increased. Next time, I am going to compare this with 2. Does it match? No. So again, I increase, compare, Does it match? Yes. Once it matches with the value, I immediately print the element is found. Once I print the element is found, I am not going to check further. This will not continue. We break here, we come out. No need to check further till the last, because we have already come to the conclusion that the element is found. Now, let us take another case. Instead of this 6, I have an array. I input the number to be searched. The values are 8, 2, 6, 4, 1. I want to search the element 7. Now, is it present in the array? How do we do? So what we are going to do, again start my value from 0, compare, doesn't match, I increase, 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 compare, doesn't match. So finally, I will come to the position of 5, which is nothing but crossing the index of size minus 1, and I come out of the loop. Now, in this case, when I come out of the loop from the last, then I can conclude that the element is not found. So here, in this case, we have taken an array whose size is 5. And I have checked till index number 4. Now in the second case, I have crossed this 4, I reach at 5. That means I reach at the position of the size. So once I reach at 5, I come out of the loop, print it is not found. Now this is the logic for behind the searching of linear concept, linear search. Now let us see the algorithm of this or the function for this linear search. Now let us take for this searching, I'm using a user defined function. We can call this from the main function when you want to execute it. Now the prerequisite for this function will be I should have an array which has all the elements present. I should have the number to be searched, which I have already inputted in n, and I must know the size of the array. These are the 3 things which must be known before we come to this particular function. So I will be taking those 3 things as parameters, and accordingly we will be going for writing them. The first is the array must be existing. So the elements which are present in the array, it is already fed, and that is passed as a parameter into this function. The second thing that I need is the size must be known, which is passed as the parameter. The size of the array, in my previous case, the size of the array was 5, and these are the elements present in the array. Now the third thing that I need is the number to be searched, the number which we are going to search. Now these are the 3 things we will be taking as parameter. Now we enter into the, now inside this code we will be using a variable that is I, which will be used for the loop concept, and we will start our checking. What we have done here, we have taken an I, it starts from 0, goes up to size minus 1. Inside this loop, we compare the value of a of I with m. So my comparison starts from a of 0, goes up to either you write here I less than equal to size minus 1, or you can write strictly less than size. Both are same. Any one of that you can use. And every time I value is increased. Now inside the loop, as you can check here, what were we doing? I start from 0. Now I already have my n. I compare the value present in n with a of I. If it doesn't match, then I increase the value of I. But if it matches, then immediately I print it is found. I come out of the. Now let us do that here. So checking means if who is compared with whom? A of I is compared with n. Now, if it matches, what should I do? I print the element is found. Now, once I have found the element, as already mentioned here, once you find the element, no need to check further for the end of the array. I can immediately come out of the loop. So, once I have found the element, I need to come out of the loop. Now, how to forcefully come out of a loop? That is the use. Let us see the logic. Initially it is 0. 0 is less than equal to size minus 1. Our size was 5. So less than equal to 4 is true. Enters. A of 0 is compared with n. If it doesn't match, it will not enter into this. I plus plus. I becomes 1. 1 is less than equal to 4. True. A of 1 is compared with n. Suppose it doesn't match. I plus plus. I becomes 2. 2 less than equal to 4. True. Suppose A of 2 matches. I print found. Come out of it. This is if we have found the element. Now let us the case is we do not find the element. So first I will be 0. Doesn't match. Doesn't match. I plus plus. I becomes 1. Doesn't match. I becomes 2. Doesn't match. 3. Doesn't match. 4. Doesn't match. Now when we increase the value of I, it becomes 5. 5 less than equal to 4. Condition becomes false. I come out. So that is what I will be checking. If I have come out when the I value is equal to size, which we had done here. When I come out when I value is size, then I print it is not found. Outside this loop, I check if I value has come out when it is equal to size. So in that case, what should I print? Element is not found. So we have checked found case. If the element doesn't match, finally this will become true. This will be. So this was an easier searching concept which is known as your linear search. But the problem is in linear search, if the array elements are very large, worst case, suppose I do not find the element, in that case I have to search till the end of the array. That means if my size is 100, I have to search 100 times. Then only I come to the conclusion that the element is not found. Now imagine an array with size or the elements as 1000. To conclude that the element is not found, I have to check 1000 times. Then I come to the conclusion that yes, it is not found. So when the numbers become very large, this particular search slows down. That is why we opt for the second one, that is binary search. Now, let us see what is the concept of binary search. Now, as already mentioned, binary means two parts. So, what we are going to do first to apply this concept of binary search, our array must be sorted. If the elements are not sorted, we can never apply binary search. That is the prerequisite of binary search. Now, let us say the elements are sorted. These are my elements present. And they are sorted in ascending order, let us say. Now, what is the process of this binary search? What we are going to do, we are going to take the first index as low, the last index as high. So, in my array, these are the elements. I take the first element's index as low, the last element's index as high. Now, once I have got the index value of low and high, then I try to calculate the index of mid. Now, how do I get the value of mid? It is nothing but index value of low plus index value of high divided by 2. And it is integer by integer. We will only take the integral value. So, for example, if the added value of low and high comes to 14, then by 2 is 7. But if the added value comes to 15, 15 by 2, the integral value is still 7. It is not 7.5 because integer by integer returns always or gives always an integer value. So once we have got this mid, what we are going to do, we are going to compare the number to be searched, the number which n, which we are searching. That number is going to be compared with mid. That means whatever value is present in this mid, this is going to be compared with my n. Now, when I compare it with the value of n, I will be getting 3 options. The first option is it may be same. Now, if this value and this value are the same, then what is the conclusion? I have found the elements. So if this is the case, I print it is found. Now let us take another case. When I compare this with this mid, let us say A of mid, whatever value is present here, this value is greater than my n. Had it been equal? Found. Let us say it is greater. That means the value present here is greater than my n. If the value present here is greater and the elements are sorted, as per the prerequisite, array elements are sorted. So since it is sorted, if this number is greater, all these numbers will also be greater definitely. So we need not check those numbers. So our concentration will be now only on this. That means if this is greater, I am going to check only these numbers which are previous to this. Among this may exist. So what we are going to do, we are going to bring this high to this position. That is mid minus 1. Because we have already compared it with mid. So it doesn't match with mid element. So we have come here. Now we found it is greater. So no need to again compare this element. If I take mid minus 1, that will be the new high and low remains same. Again, same process will be applied. That means again I calculate mid, find the element in the mid, compare this with mid. Again I will get three options. Either it is equal. If it is equal, I print it is found. If it is not equal, either it will be greater. If it is greater, again I must search this portion again with the same process. Let us say I get this condition. Now, the value present in A of mid, let us say this one, is less than my number n. Now, if it is less and prerequisite was these elements are sorted in ascending order. So since they are sorted and this element is less, definitely next time I am going to search only this, because these elements will always be definitely less than that particular n. I have no need to search them. I go only to the right side. So my high remains same wherever it is, but my low now comes to mid plus 1. Now, again for this, again I calculate mid, this process. Finally, a situation may come where I will have my low and my high at the same position. That is one position. One element will be present. If it doesn't match, next time when I again go either to calculating the mid, going to left or going to right, what happens? My low value will cross my high value. So once this case happens, that means low index crosses the concept of high, then I can conclude the element is not. Again I repeat, in binary search, first is it must be sorted. We are taking the example, it is sorted in ascending order, let us say. Once the elements are sorted, then only it is possible to apply binary search. When we apply binary search, first I choose high and low, that is low and high. From that low and high, I calculate the mid. Once I calculate the mid, the number to be searched, that is n, is compared with the mid. When I compare with the mid, I get three options. Either it will be equal, or it will be greater, or it will be less. Three options. Now, if it is equal, I have found the element. If it is not equal, then I check these two. It may be greater, it may be less. Now, if the number is greater than n, the middle number is greater than my n, then I should search the left. So my high changes. So in this case, high is going to change. But if this number is less than my number n, then I am going to search right side. In that case, my low is going to change. So if this is true, my high is going to change. If this is true, my low is going to change. And again I am going to repeat the same. For the new high, new low, again I calculate mid, compare n with mid, and the process continues. Finally, if my value of low crosses the value of high, so this was my low, this was my high. After breaking, low comes here, high is here. After breaking, low, high comes here, low is here. Like this I go on dividing. Finally, when this low will cross high, at that point I come to this conclusion not. So in between, if I have found the element, no need to check further, I come out of the loop by using the break. But if I have not found anywhere, only these cases are matching, then finally a situation will come where the low will cross the high and I print it is not found. This is the process of binary search. And here it is more optimized than linear, because let us say there are 100 elements. I compare this with the middle element. After one comparison, half of the elements, either left or right, will be eliminated from my search. That means in one comparison checking, I am eliminating 50% of the elements of the array. It comes down now to 50 elements. 50 elements, when I make the second comparison, again 25 elements are eliminated from the compare search. So this works very fast in comparison to our previous, that is linear search. Now we have seen the logic. Now we'll be going to the algorithm or the code of this particular binary search. As previously in the case of linear search, we had taken the array must be existing with the elements, the size must be known, the number to be searched must be known. Similarly, for binary search also we'll be taking these three. The array must be existing with the elements and sorted array. That is the prerequisite. Second, the size must be known. Third, the number to be searched must be known. So let us come to that. We are going for binary search, a user-defined function. You can call this function from the main to execute this particular function. Now, as mentioned earlier, this function will be requiring three things to be already existing. One is the array elements, which will be passed here. Second is the size or the capacity of the array. Third is the number to be searched. Those three will be coming as parameters into this function and we call it. First one is array, consisting all the elements. Second is the size. Third is the concept of the number to be searched. Now, inside this, we will be using some other variables. As seen already, we are using low, high, mid. So these are the variables which we will be using there. So let us declare them. Int, low, high, mid, coming to our logic. Initially, at the beginning, what was the position of low? The first index. Now, in an array, what will be the index of the first element? 0. So that 0 will be our low. Starting value of low is equal to. Coming to our second, high. High is nothing but the last index. Now, what will be the last index of the particular array? Let us say the capacity or the size of my array is 5. If it is 5, my first index will be 0. Last index will be 4. If my capacity is, let us say, 100, my first index will be 0. Last index will be 99. So if the capacity of my array is, let us say, size, then the first index will be 0. Last index will be index size minus 1. So this is the index size minus 1. That is what we are going to initialize. So we have got the first index, that is 0, the last index, that is size minus 1. Now, after getting this, we were repeating this concept. Now, repetition means there will be a concept of a looping structures. So, this particular thing was repeated. I compare with middle, either I go to the left or I go to the right. Again, I compare with middle, either I go to the left, go to the right. This is a repetition process. So, for the repetition, we will be going for the concept of a loop. Now, you can take any loop. We will be taking here, let us say, a while loop. So, next will be a while. Now, this loop will continue how long? Let us check. Low is here, high is here, the loop continues. Low is here, high is here, the loop continues. Low is here, high is here, loop continues. But whenever low crosses high, the loop stops. That means whenever the value of low is less or equal to the high, then the loop is continuing. Again I repeat, the value of low is less or equal to my high, then the loop continues again and again. So, condition will be value of low is less or equal to my high, then my loop is going to continue. Now, what have we done here inside the loop? I have got my low, I have got my high, my low value is less than my high, so the loop is going to continue. Inside the loop, the first thing that we calculate is mid. Let us calculate. Now, what is the value of mid? How it is calculated? It was nothing but low plus I by 2. Index value of low plus index value of high divided by 2. And it is integer division. That is, integer by integer always takes the integral part only. Even if fraction part comes, it will be ignored. The fraction part will be ignored. Only integral portion is taken. So, we have calculated mid. After calculating mid, what was our next step in the logic? We compare our n with mid. So, that is what we are going to do now. As already mentioned, we will be getting 3 options here. Either it may be equal, or A of mid may be greater, or A of mid may be smaller. So I have taken the first case. A of mid, that is the value present in the middle of the array, is suppose say matches with n. That means when I compare this with mid, it is going to match. If it matches, that means I have found. So I print Once the element is found, should I continue my search again looping? No, no need. So what we are going to do, come out of the loop, that is print. So if the value of n matches with the value of a of mid, then we print it is found. After printing found, I use break to come out of the loop because no need to check further because already I found it. Let us say this particular condition becomes false. That means when I compare this with middle, it is not equal. If it is not equal, next I should check these two. First is a of mid is greater than n, or it may be less than n. So I check those. If a of mid is strictly greater than n. Let us say a of mid value is not same, comes to this else portion. Here I check a of mid is greater than n. Now, when I check with mid, let us say a of mid is greater than my number to be searched. Since it is greater, all these numbers will also be greater because it is sorted array, ascending order sorting. So what we are going to do, we are going to only check this portion half. So high is going to come to mid minus 1. So if it is the case, who changes? My high. My high, which was here, is going to come to mid minus 1. Low remains same. If it is true, in that case, my high comes to mid minus 1. And check here. N, when I compare with A of mid is greater. Since it is greater, all these elements will also be greater. So I have to compare only next time with this portions. So my high comes to mid minus 1. If it is false, this is false, it doesn't match, comes here, this is false, that means A of mid is not greater than n. If it is not greater than n, then what am I going to do? I am going to again check the next. The third option will be my A of mid will definitely be less than n. This I have checked, it is not equal. This I have checked, it is not greater. So next, by default, A of mid will always be less than my n. Now, if A of mid is less than my number, that means my low is going to change. Next time I am going to compare this because all these elements will also be less since it is ascending order sorted. So only this will be checked. That means low is going to be changed. Low comes to mid plus 1. So else who changes? My low comes to mid plus 1. Okay. So if it matches, print found, come out of it. If it doesn't match, check the next. If it is greater, high changes. If it is false, low changes. Yep. So this is a loop which will go on continuing, which we have already seen. This goes on checking with all that. Now we have to check this. Now, how do I know this? My value of low crosses the value of high. So, if my value of low becomes greater than my high, then I can conclude this is not false. So, somewhere in middle, if it matches, then definitely my low value will be less than high. In that case, I am not going to print this. So, I am just going to check here outside this while, if my value of low is greater than my high. That means they have crossed. The low, high. Low has crossed high. So, if it is true, in that case, I print this is the algorithm code or the user-defined function which we have written for binary search. So we have seen two things. One is the concept of linear search. Second is the concept of binary search. So searching, two types. One is your linear search. Second is your binary search, which we have already seen. Now, among these two, which one will be preferred or which one will be faster? Definitely binary search. But the concept is, for binary search, you should have the array in sorted. If the elements are not sorted, then it is never possible to apply the concept of binary search. So, prerequisite of binary search is sorted array. That means first we must sort the elements, then only we can apply the concept of binary search. So to sort the elements, first we sort it by using some sorting algorithm. Once the elements are sorted, then only you can go for the concept of binary search. So we have seen two things. That is, one is your normal search or the linear search. Second is the concept of binary search. And as already mentioned, for binary search, prerequisite sorted array. So that is the importance of our without sorting, you cannot go for binary search. So first you must sort the elements, then you can go for binary search, which will become very fast. Now there are different sorting methods available. Now among them, the optimum one or the faster ones are merge, quick. We will be discussing now the concept of merge sort. Now, what happens in merge sort? Now, merge sort is actually broken down into two steps. The first step is breaking. Breaking the elements or the elements of the array. The second step is merging. Now, while you are going to merge, that time you apply the concept of sort. So, step number 1, breaking or break. Step number 2, once breaking is over, then we come to merge. By merging, sorting is applied. Now, we will see that in a diagrammatic view. Let us say This is my elements. So what we are going to do, just like our previous, we are going to have a low, we are going to have a high. So our first index will be our low, our last index will be our high. Now we are going to calculate mid. Just like our previous, mid will be calculated as low plus high by 2. Now once I have calculated the mid, my low to my mid, up to my mid will be my first list. My second list will be from mid plus 1 to high. So this is breaking. I have broken my list into two parts. The first part is from low to mid. Second part is from mid plus 1 to high. So this will be my low. This is mid. This is mid plus 1. Now, once I break, again the process is repeated for this left, then again right. Now, for this new, now this becomes my low, this becomes my high. This becomes low, this becomes my high. Whatever I did for this first low, high, calculate mid, same thing will be repeated for this. It will be a repetitive process, or it will be a recursive process, what you call it. So again I calculate mid, low to mid, mid plus 1 to high. Again this becomes my low, this becomes my high. Again I calculate mid. So like this I go on. Then finally it will happen that I come to a single element. My low, my high, both come down to a single element. Once I come to a single element, my breaking is going to stop. The first portion is over. So I go on breaking till I come to a single element. Once I come to a single element, then my left hand side breaking is over. Now I shift to my right. So if I take this is the left, this mid plus 1 would have been my right. For the right, again I have the same thing, low, high, go on breaking if it is more than one element. If it is a single element, stop. So left hand side breaking is over, right hand side breaking is over. Now I come to the second step, that is merge. Now while I am merging, I am going to apply the concept of. Now let us say for example this element is 4, this element is 2. So when I am merging between these two, who will come first? Then who will come? Because they are sorted. We are applying sorting. Now once this merging is over, this was the left, there is a corresponding right. Again I continue the same thing with the right till it comes to a single element. Then again this merge with the next. This is the process how it goes. That is the concept of merge. So you can again just see what is happening. There is a low, there is a high. I calculate the mid. Once I find the mid, my first list is from low to mid. Second list is from mid plus 1 to high. For the first list, again I repeat the same thing. That is, again it becomes a low, high, mid. First list is low to mid. Second one mid plus 1 to high. For this first list, again I calculate mid. This process goes on till I come to a single element. Once I come to a single element, my low and high will be at the same position. If my low and high for the new list is at the same position, then I know it is the concept of single element. That time my breaking stops. Once my breaking stops, I move to the corresponding right. Repeat the same process. Now right side, corresponding single element comes and breaking stops. Left hand side breaking is over, right hand side breaking is over. I combine them. That is the known as merging. While merging, we will go for the concept of sorting. That is the basic process of merge. Let us take a simple example with some numbers and try to do this task of making this merge. Some random numbers I am taking. Let us say the first number is 6, the second number is 2. Random numbers. First number is 6, second number 2, third number is 9, let us say. Next number is, let us say, 4. Some random numbers I am taking and I am going to apply the concept of merge sort. Then next number, let us say 7, 1. So now when I put them into array, this will be index number 1, 2, 3. Okay. So I have 6 elements. I am going to apply merge sort to these 6 elements. You can take a bigger example to make it more clear, but whatever process we are going to do it for this 5 elements or 6 elements, the same process will be applied whether you take 10, 100, 20, whatever it is. Now, what was our first step? Low, high, then we go for mid. This is my low, that is index number 0, my high, index number 5. Now I calculate my mid. How do I calculate mid? Low plus high by 2. Now, so 0 plus 5, that is 5. 5 by 2, as I already mentioned, integer divided by integer, only integral value will be taken. So 5 by 2, integral value will be 2. So my mid is at 2. Now, once I have got the mid, then I get my first list, second list. So who is my first list? Low to mid. So my first list is 6, 2, 9, index number 0, 1, 2. This is my low, this is my high. Now, again I will repeat the same thing what we have done earlier. Calculate mid, that is low plus high. 0 plus 2 by 2, that is 0 plus 2 is 2. 2 by 2 is 1. So my mid element is 1 or mid is 1. Again I go for first list. First list will be from low to mid. 0, 1, low, high. Now again you calculate mid. Low plus high, 0 plus 1, that is 1. 1 by 2. Integral value is 0. So this is also my mid. Again, first list is from low to mid. That will be my low. That will also be my high. Now since my low and high both are same, now I know it is a single element. I stop my breaking. You can just check. whenever I was coming to a single element, low and high were becoming same, I stop the breaking. This process stops for the left side. So I have come to a single element, so my left side breaking is over. Now I go to the corresponding right. So when I had taken low to mid as my left, my right was mid plus 1 to high. That means mid plus 1 is this, high is this. This was the second list. Index number 1, that is now my new low. High, since my low and high are now same, I can merge. While merging, now who is going to come first? 2. So left side breaking is over, right side is breaking is over. I merge them both and I put it in this A of 2 and 6. They are sorted. This elements. Now this was the left of corresponding right there is there. So let us go to the corresponding right. These two elements were the left, low to mid was my first. Mid plus 1 to high will be my second element. So mid plus 1 to high means it is that element 9. Now this 9 at index number 2, this is now my new low, new high. How many elements? Single element. So since it is single element, it is now we have merge. Now left and right has been over, so we merge them. While merging, sorting is applied. Now these three elements were again a left. There is a corresponding right. Who were the corresponding right? 4, 7, 1. This is index number 0, 1, 2. This is 3, 4, 5. Now this is my second list. For the second list, again I will have the concept of that is low, that is high. Now, if I take this, no space here, so I am just continuing it in the side. You have to continue here for your clarity. So I am writing it from the side. This is 4, 7, 1, index number 3, 4, 5. This is my low, this is my high, this is my mid. How did I calculate mid? Low is 3, high is 5, 3 plus 5, 8 by 2, that is my first list will be from low up to mid. That is index number 3, 4, this will be my low, this will be my high. So, low, high. So now, again, for this new list, again I calculate mid. 3 plus 4, that is 7 by 2, it is 3 integral value. So this is again my mid. Low to mid, that is my single element. This is my new list. Now I have come to a single element. So breaking stops on the left. Now I should go to the corresponding right. For this low to mid, mid plus 1 to high. This was index number 4, the value is 7. It was again a new low, high, single element. So breaking stops. Left hand side breaking is over, right hand side breaking is over. Now I should go for merge. So while merging, index number 4, 3 and 4, 4 comes first, then 7 comes because I am sorting in ascending order. Now left is over. There is a corresponding right for that. Who was the right? 1, index number 5. So low to mid was my first. Mid plus 1 to high will be my second. Mid plus 1 to high. Again, there's a low, there's a high. single element, left one is over, right one is over, I merge, so it becomes 1, 4, 7, because while merging, I am going to apply the concept of sorting. Next, this was the right, this is the left. So I take this from here, that, and this will be merged to get first between this 2 and 1. 1 will be coming, then 2 will be coming, then 4 will be coming, then 6 will be coming, then 7 will be coming, then 0, 1, 2, 3, 4. As you can see, this is sorted. That is the process of merge sort. Now, first thing is breaking, second thing is merging. Now, while merging, as you can see in these two cases, while merging, we are comparing the values. Whoever is less, that is going to come. So this is regarding the logic. Now, once the logic is over, we can go for the concept of coding. We can go for the concept of coding of this particular. Now, two steps. One is break, one is merge. For breaking, we'll write a separate user-defined function which will be recursive. Then we will have another function for merging. Now let us write the first one. I am going for breaking. Okay. Now when we were going for breaking, we were having one, the existing array, the second, the value of low, value of high. Array must be existing, which is passed as a parameter. Second is the value of low. Third is the value of high. First time when you call this function from your main, array will be passed, low value will be 0, high value will be nothing but the capacity minus 1 or size minus 1, which will be passed into this function. Now inside this break, we were using low, high was already passed. We were using a concept of mid. Let us declare it. So the other variable which we use, that is mid. Next I check if my value of low is strictly less than high. This is checked to indicate in the list there are more than one elements, because if it becomes a single element, in that case this low will be equal to high. So if it is true, that means in the list which has been provided there is more than one elements. If it is more than one elements, then what were we doing? Calculate the mid. How do I calculate mid? We have already seen, that is low plus high by 2. Once you calculate the mid, low is here, high is here, I calculate the mid level or the mid index. Once I get the mid index, then I am going to break, which we already did. Once I got the mid, we were going for breaking. Now when we went for a break, The first list was low to mid. Second list was mid plus 1 to high. That is what we are going to do. In this case, merge rate. Recursively, I am again calling this function. First value is my array. The first list is from low up to mid. So this will be passed. Next time, this mid is again going to become a new high. This mid is going to become a new high when I call it again. So that is what we have done here. I am passing the mid. I am calling this function. When I call this function again, that time this mid will become my high. Now, this was the first list. My second list first list low to mid. What was our second list? Mid plus 1 to high. Second list is mid plus 1 to high. Now, first list is broken, second list is broken. So first list is breaking is over, second list breaking is over, recursively it goes on. Then we come to second step, that is merge sort. Up till now, we have not written this code of this. We will be writing. This is a user-defined function. So inside this, we are calling another function, that is merge sort. Till now, we have not written the code. Just after this, we will be seeing the code of this merge. Now, in this merge sort, we pass the array. The existing array is passed. Then we pass the value of low, value of mid, and the value of high. So we are going to merge the left hand side and the right hand side. While merging, as already mentioned, we are going to sort the elements in ascending order, and this merging will be done based on this. So we pass the low, we pass the mid, we pass the high. Now, end this if, end this. So this is our first step of breaking down. Once we have broken down, then we are going to write this code for this merge. How many parameters it takes? The array, existing array, value of low, value of mid, value of high, which are passed. Now let us write the code for this, which is actually the gist of this sort. So if we come to our merge sort, it was taking how many parameters? 1, 2, 3, 4. Those parameters will be written. First one was the existing array. Second one was value of low. Third one was value of mid. Fourth one was okay. So what is the work of this particular user-defined function merge? Here, what we are going to do, we are going to merge two different arrays. Now, what we are merging, these two arrays are already sorted, as you can see here in the example. when we are merging these two, or we are merging these two, the elements present in these are already sorted. So we are going to merge them. While merging, we are again going to apply the concept of search. So let us take this example. We will go into that. This is my left, this is my right, and I have merged them to this. So that example will be seen there when we go. Okay? So in this merge sort, what we do, we are going to have one array, second array. First array is already sorted with its elements. Second array is already sorted with its elements. Now we are going to merge them together. While merging, we are going to also apply the concept of sort. So here what we will do, for easy, we will take another array. Let us say one array is A. I have taken another array B. In this B, we will be copying these elements actually. These elements are present. These elements are present. When I copy it here, if I overwrite into the same array, this element may be lost. So what I am going to do, I am going to merge them and put them in a second array, that is B array. Finally, this B array I will transfer to original A. So think this is a B array. This is the first part of my A array. This is the second part of my A array. Now we are going to merge it into B. Now I will just draw this there for your easy understanding. 2, 6, 9. So it was something like, I put it here. 2, 6, 9. This was one array. Then 1, 4, 7. This is my second. 1, 4, 7. This was my second. This is like number 0, 1, 2, 3, 4 of array A. Now, what we are going to do, we are going to merge them, put them into another array. Now, this will be fine. So, while merging, we are going to apply the concept of sorting here. So, you can check 6 to 9, that was coming here on the left. 1, 4, 7 comes. This is how. So, that logic will be right. So, for that, I have used this array B. Now, apart from this B, what are the other variables that you will be needing? I will be needing a I, a J, and now where I will use, I am going to use I for this, J for this, K for this, to keep the index. So, I am going to deal with this first, J is going to deal with this second, K is going to deal with the new array. So, that are the three we have used, I, J. Now, if you take this original array A, this was my concept of low. This was my mid. The other array was mid plus 1. This was my high. So, what is the starting point of I? Or what will be the starting point of I? As you can see, I value starts from low. Similarly, what will be the I starts from? What will be the starting value of J? Mid plus 1. the starting point of k. I is at 0, j is at 3, k will start from 0. So it is nothing but same as I. So k value starts from. Now what we are going to do? We are going to transfer the elements from this 2 into this. While transferring, we have to check whoever is less, that will come first. Then accordingly, the particular index, either I or j, will be incremented along with. So this will be the process. So this will be repeated. This will be repeated a number of times. Now since it is going to be repeated, the checking between these two elements, first this element will be compared with this, then one will be transferred, next again comparison, transferred. So since there will be repetition of some values or codes, we are going to use the concept of loop. So let us take a look there. Let us take a while. Now, how long it is going to continue this loop? This loop is going to continue till elements are present here and elements are present here. That means the first part has elements, second part has elements. How will I know? I value is at low, that means element is present. Next time I comes here, next time I comes here, next time I comes here. If I value crosses this mid, then I know the elements are over from the first. Similarly, when I come to the second, j starts from mid plus 1, that means elements are present. J comes here, element is available. J comes here, element is available. But if j crosses high, then I know elements are not available. So what I am going to do is, this loop will continue till I value is less or equal to mid. That means elements are present. If I cross the value of mid, then I know I have crossed the array and elements are not present anymore to be transferred to the next array. Similarly, I must check the second, that is j is less than equal to. So if j value has not crossed high, that means elements are present in the second one, I can transfer. If j value crosses high, then no need to go for transfer, I know that is second element. So this loop is elements are present in first and elements are also present in second. If elements are present in both, now I must compare the first element with this first element. That is a of I with a of j. So if I compare a of I with a of j, either it may be less or it may be greater. I don't know which one will come, but either this number will be less than the previous number or it will be greater than the previous one. So I am going to check those two cases. That is, either it is less or it is greater. Those two cases will be checking. So if a of I, let us say check for less than a of j. In this case, it is not true. Okay. Had this been 1, this been 2, then it will be true. So if I check if a of I is less than a of j, suppose this value would have been less than j, then what I would have done? Who would have been transferred? Or let us convert this, reverse this, because this example it is great less, so we will take that less itself. Let us take it greater. A of I is greater than A of J. Now, in this case, who is going to transfer to B of K? A of I or A of J? A of J. So, if it is true, the lesser number is transferred to B of K, gets the value of the lesser number. So, A of J is transferred to B of K. That means this 1 will come. Now, after 1 comes here, now I increase J, I increase K. I have transferred. So, after transfer, K is increased and J is increased. So, that is J plus plus K plus plus. You can write it in separate lines. I have just written in the same line, putting semicolons. So, if it is true, AJ is transferred to B of K, J is increased, K is increased. J is increased, K is increased. Again, I check elements are present in first and elements are present in second. Yes. Again, it compares A of I greater than A of J. So now A of I is compared with A of J. Is A of I greater than A of J? No. So it will come to which portion? It will come to the second case. That is else. Now, in this else, between this AI and AJ, who is less? AI. So, A of I is going to be transferred to B of K. So, else B of K gets the value of A of I. So, this 2 is transferred here. After I transfer 2, I increase I increase K. That is I plus plus. Okay. Now again, we come here, elements are present in both. Now A of I will be compared with A of J. Who is less? AJ. AJ is going to be transferred. This will become 4. This value is transferred. Then A is increased. J is increased. Next time, again A of I compared with A of J. Who is less? A of I. That is going to be transferred. I increase I increase K. Next time, who is less? AJ transferred, increase J, increase K. Now you can see this has crossed. That means elements are no more present in the second array. So out of these two conditions, one of the condition will become false. That is, this condition becomes false. Now since there is a AND, double ampersand, if both conditions are true, then this was being done. Now, since one of the conditions becomes false, it comes out. So, after it comes out, but still elements are present in first. So, that is what I check. Out of these two, which one has become false? How do we know? I write while I less than equal to. One of them has become false. I come out. I individually check those conditions. If it is true, that means this was true. This has become false. So second list elements are over. I must just to transfer from first. So if it is true, I will transfer elements from first list. That is from AI to BK. So BK gets the value of BK gets the value of AI. Now once BK gets the value of AI, this 9 is transferred here. K increase, I increase. Here it was one element. Had there been more than one elements also, all would have been transferred. Now after transferring, I is increased, K is increased. Now this was the case where the second element ends, second part elements are over, first part are getting transferred. Suppose it was different, second part elements are there, first part has been transferred already. So I need to transfer from the second part. In that case, again I check y j less than equal to high. So in that case, this will be false, it will not go, this will become true. So in that case, B of K gets the value of A of J. Then J plus plus K plus plus. So either elements will be getting over from the first or elements will be getting over from the second. If it is getting over from the second, I have to transfer from the first all elements. If elements are over from first, I have to transfer everything from the second element. That is what we have done. If this is true, both elements are present, means this is done. One of them becomes empty, either this or this will work. Now, all my sorted elements are now in my array B. So I just need now one loop to transfer all these elements back into A, taking any variable, maybe I, J, K, anything. So we continue here. I don't have space, so I am continuing here. For I is equal to, starts from where? Low up to high, each time increase by 1. Starts from low up to high. Inside this, A of I gets the value of it is just a transfer of all the elements from this array B to array A. Then end of this. So this is the program or the function for merging two sorted arrays. Okay, so first array was sorted already, second array is sorted. When there are single elements also, this will be done. When there are more than one elements also, this will be done. So two sorted arrays are merged here, and this is no nested loop. This loop ends, then this loop, then this loop. So it will be comparatively faster than nested loop concepts. So that is the concept of merge sort. 2 steps, break, then merge. While merging, going for the concept of sort. This is the code. So this is the code we have seen today. Searching, two types, linear search, binary search. For binary search, we need sorted array. Then we saw sorting methods. In the sorting methods, we have seen merge sort. For merge sort, step number 1 was breaking. Once breaking is over, then we go for merging. While merging, we go for sort. And this is it. Thank you.